done. Hello, guys. My name is Desmond, and I welcome you to my lesson for today, where we'll be looking at your mathematics. So, ladies and gentlemen, please do allow me to say it is very much important that I say it is very, very much important because what I'm about to say, it's massively important, ladies and gentlemen. A day without learning something new, it's a day wasted. I just heard someone saying, I'm breaking. Is it the same for everyone? Let me quickly see. Retabile.
No, you're clear.
Clear. Okay,
clear,
guys, please do make sure that by the end of each and every lesson that I conduct, you learn something new. As you can see over there, Bantu Bakiti, I'm going to prepare you for the test that you'll be writing this coming Saturday. It will include some of this type of questions. So please make sure that you do not allow me to continue without you understanding each of these questions. I'm hoping to cover all these questions in today's lesson. So without any waste of time, let's start with the first question. Once we are done with this type of questions, then we know that regarding the laws of exponents, we are sorted. Okay, here comes a question. Is this a math problem? Yes, it is a math problem. Another question, what type of a math problem is this? Based on what we discussed, we have got what we call a linear, a quadratic, an equation, an expression, and inequality. So here, this type of a math problem is what we call an expression. What do we do when we have an expression? We simplify. When we have an equation, we solve. But in this case, we have an expression, meaning we simplify. What does simplify mean? It simply means that you rewrite all of these, but in its simplest form. So it's more like what examiner was trying to do there. It was to give you something which is complicated that you need to rewrite in its simplest form. So now, the last question that you should be asking yourself, how are you going to approach this type of a question? Very, very much important, ladies and gentlemen, over there. I did indicate to say you need to understand the type of a math problem that you are dealing with so that you'll be able to easily work it out. So when you look at that, are you having a number to the power of letters, or are you having letters to the power of a number? Is there someone who can tell what are we having there? Qinile, do you want to guess?
Numbers, letters.
Yes, base being the number to the exponent of a letter. What does it mean? Based on what I explained, it means you need to apply the laws of exponents because you are having an exponential type of a problem. Okay, so now let's apply those laws that we learned. If you remember, guys, we did say in this type of problems, you always try by all means to have these numbers in their smallest basis. Carol, I'm not sure if you remember what honorable member said. She said something like, was it Tabile? I can't really remember who was that honorable member. She said something like, is there someone who remember how we convert that to something being the base to the power of something? I think she said we punch 4. We say it's equals to, we do shift, and then we do this thing of dotted. Yes, that's what she said. Do you guys still remember? For those of you who were not there in that lesson, we want to try and rewrite that base as 2 to the exponent 2. But there's a way in which you can do it, especially when you get to values such as 72. Instead of you having to figure it out, you can just use what honorable member said. So she said you punch 4 and then you punch is equals to. Can you say 4 is equals to? Then it gives you 4. Then she said you need to punch shift. After punching shift, next to this sign of negative, between this sign of negative and hype, there's this thing which looks like that. You punch that button and then it gives you a 2 to the exponent 2. So that's how you know that when it comes to 4, it can be rewritten as 2 to the exponent 4. Let's see for 9. So for 9, you'll also do the same, but we know that 9, it is the same as, what is it? Is it 3 squared? Yes, I think 9, it is 3 squared. But remember, inside the brackets, because you're only working out this bigger number in a form of a base to the power of something. This is to the exponent of n minus 1. You also do the same for that one. Can you see for 72, it's a bigger number. You might need that method. So you say 72, it's equals to, you say shift, and then you do that. This is what it gives you. Can you see? Okay, let me ask, what are you guys getting for 72?
2 power 3.
Someone is saying 2 power 3.
Times 3.
Times 3.
2. Power 2.
2. 100%. So, guys, I'm going to continue with an assumption that it all made sense to everyone. Maybe before I do that, Carol, are you sure we are not confusing you on that one? Are you sure there, Carol?
Yes, totally sure.
Totally. Are you confused on that one? I couldn't hear you there.
No, sir, it's fine.
Okay. Mzozozo, are you sure you understand what we did there on that 72?
Yes, I got it, sir.
Okay. So whoever who did not get it, just make sure that you let me know and then I'll quickly um, explain how it's done. So that means it's actually 2 to the exponent 3 multiplied by 3 to the exponent what? She said 2 there. And then this is what? This is n plus 2. And then this one for 2, even if you do it, I think it will just give you 2. So it can have a base to the exponent something. So you just write it as it is. So this is your first step to this question. I'm just not sure if we're still on the same page up to this point before I go deep.
So may
I
I
made a
ask where
mistake.
did the 2 come from?
That question.
Oh, yes, I noticed my mistake. Someone is saying a question. What's the question again?
You see where the down one, yeah? 2 power 2
Yeah.
times 3. Then that n, why are you putting plus 2? Where do you get that 2?
Oh, yes, that's where honorable members are saying I made a mistake. So I noticed that one.
Oh, okay.
So
Sure.
thanks very much for noticing that. So it's actually a mistake. So it should be just a n. So which is a very good indication that we are all on the same page. So now, can you guys see? I'm not sure if Busisiwe is here because she's the one who will tell you that when it gets to this stage, we do what we call power to power. So power to power, this power multiplies that power, this power multiplies that power. So that means we're going to have 2 being the base, then power to power. Let's see. That means we're having 2n plus 2 times 2, which is 4, multiplied by 3 to the exponent power to power. So that means you are having 2n minus 2. The whole of that divided by, can you see, guys, power to power. So that means you're going to have 2 to the exponent 3n times 3 to the exponent 2n multiplied by 2 to the exponent 1 minus n. So I'm pretty much sure that that was a straightforward calculation. So now, remember, guys, in case if you don't have, is it a question coming through?
I don't understand where I go till by 2 power of 3 times by 3 power of 2.
Which one? Is it this one?
No.
Which one? Is it at the top or at the bottom?
The second step.
This one.
Yes, the 2 power of 3 times by 3 power of 2.
Oh, this is where you're referring to. Ne? I suspect that's what honorable member is referring
Yes,
to. So let me quickly explain that. Okay, maybe I notice what is actually confusing you there. So can you see, honorable member, here, for example, you are having one power inside, so it multiplies this and it also multiplies that. But on this a problem, you are having one number being the one outside, so it also multiplies that and also that. So that is why you end up having that by that, which is 3n for the base of 2, and then that by that is 2n for the base of 3. Does it make sense there, honorable member? I think it does. Listen to her. She's going to say she understands. Okay. Let's see. I'm still waiting for your response, honorable member. But in the meantime, let me say, in this case where you are not having a sign of a plus or a minus separating the terms, that means you are looking at some things to be cancelling each other out there, which means you need to expand that, and also expand that. How do you do that? You're having the base to the exponent 2 to n there multiplied by let's see, maybe 2 to the exponent 4. You remember that law which says when you're having the same basis, you add the exponents. So now we do it in reverse, where you expand that. Remember, this is not the only way in which you can work it out, especially when it gets to this step. There are different approaches that you can apply, but I just want to make sure that I expose you to all the types of approaches that you can apply. So here, let's also expand this one. This is then 3 to the exponent 2n multiplied by 3 to the exponent negative 2. You just break those powers but having the same basis. The whole of that divided by 2 to the exponent 3n times 3 to the exponent 2n multiplied by 2 to the exponent invisible 1. You can just write it and say 2 to the exponent negative n. So now it seems like there's nothing to cancel in the numerator and the denominator part, but it seems like we can cancel this and that. I'm not sure if you guys are able to notice that. I think we can cancel those. So let's just straight away cancel them out. Then what else can we cancel? It seems like there's nothing else to cancel out with 3. It was just those. Okay, so now the other thing that you can do is to then work out the same basis with their exponents. For example, we work out the base being 2, 2, 2. How do we do that? If you remember, there is that law of exponent which says when the bases are the same, you can add them together, and then when they are here at the bottom, you can take them to the top by changing the signs of their exponents. Maybe for it to make sense, let me quickly do it and say you are having a base of 2, which is going to represent that base, that base, that base, that base, and also that base. Then the power for these two is 2 to the exponent n. The power for this base, it is 4. Then you add it to that. But this bases at the bottom having the base of 2, you take them to the top, they are represented by that same base being 2, but you change the sign, it becomes negative 3n, and then for this one, the power is 1, then it changes to become negative 1, and then for this one, it changes its power to become positive n. But remember, you still have that 3 to the exponent negative 2. Sure, I'm suspecting that I lost you there, and I'm thinking it's best to take this opportunity, Larissa, to check if we are still on the same page on that one. Guys, Lesedi, are you sure I'm not losing you there? I feel like I've lost you guys. I don't know why.
Sir,
Mm-hmm.
can you please explain how you got to the last step again?
This one, ne?
Yes, sir.
Maybe let me redo it. Who's speaking? Sneguku Nkosi. Let me quickly redo it. But before I do that, let's say, for example, you have x to the exponent 2 over x to the exponent, let's say 7. So this is basically what I'm doing, Snekuku. Can you see this base at the top? You write it as it is, as x to the power of 2. But anything at the bottom having a base of x, you take it to the top, but what you do, you are going to change the sign of its power. Meaning, because it's positive 7, you are just going to say negative 7. Where is this x? This x, it is represented by that one x. So it's more like this x represent all the x's on that. But their exponents, if it's at the top, you just plus it. But if it's at the bottom, what you do, you minus it. Maybe let's quickly work out this one. So that one was 2 there, 2 there. Okay, so can you see there, Sneguk, we are having 2 to the exponent that 2n. We have another 2 there. It's represented by that same 2. Then you plus that power because it is in the position of the numerator, or it's at the top. Then we still have another 2 there. Can you see? But it's at the bottom. So that means the 2 is represented by that still. But what you do, you minus the power there, meaning you're having minus 3n. Then we still have another 2 here, but its power is 1. So we take it to the top, that means it has to change its power. So this one here, can you see, we still have that 2 represented by that, but the power is negative n, so we write it as positive n. So it's more like these 2's, we take them and write them at the top, but when we do that, they change their sign. Just like maybe if you have 2x plus 1 is equals to 4. When you take it to the other side, that one is going to change a sign. But in this case, we don't have equals 2. We take it to the top. Snake, I'm not sure. Are you getting some light nyana there? But remember also, you still have that 3 to the exponent negative 2. Mzozozo, are you having some light there?
Yes, sir, I'm following.
Ayanda Mphahlele, are you sure? I'm not moving fast on that one because once you get this one, I'm telling you, all upcoming questions they will now make sense. Umi, Dineo, are you okay that side? Nomsa,
Yes, sir. I'm good.
okay. So now, let's see how does the next step look like. So the next step is just to work out the like terms. So we are having 2 to the exponent. Let's see. Someone remember to mute your mic. So we are having maybe we can say what is 2n plus n? That is 3n. 3n minus 3n, we no longer have n. So it's more like they cancel each other out. And we now have 4 minus 1. What is that? 4 minus 1 is 3. Yes, 4 minus 1 is 3 multiplied by that being 3 to the exponent negative 2. Guys, I'm going to ask you a question again. Did you see what I've done there?
No, sir. May you please repeat it?
Okay. Let's see. So remember, you are having a, let me get a different marker there. Let me just rewrite only this portion. That portion at the top is 2n plus 4 minus 3n minus 1 plus n. So you have the base being 2, but it doesn't really matter that much. I want to explain this, that you work out the like terms. So you can punch on your calculator 2 plus a invisible 1. You have a 3n, and you still have that 3n. So it's more like it's 3n minus 3n, which is already 0. Then it cancel out. Then you have numbers being 4 there minusing that one. What is that? This is equals to 3. That is why we're having 3 there with the base being 2. Does it make sense to everyone? I think
Yes, sir.
it
Yes,
does.
sir.
Yes. So now, what is 2 to the exponent 3? I think that is 8. Yes, I think that is 8. So I'm not sure if you guys remember on one of the rules, we said if we are having, let's say, if we are having x to the power of 2 multiplied by y to the exponent negative 4, we said we don't want to be having a negative power. So what we're going to do in this case is going to be x squared over y to the exponent positive 4. It's just like we have done somewhere, I think there, where we're saying, for example, if this negative was at the bottom, you take it to the top as a positive. But in this case, it is negative 4, then you rewrite it as a fraction. So what I mean by that is this 2 to the exponent 3x, which is more like that, and then this one being 3 to the exponent negative exponent, which is like that, you will rewrite it in this format, meaning you're going to have a over 3 to the exponent a positive 2 as the power. So now, obviously we are having 8. What is this thing on a calculator? I think it's 9. Yes, I think it's 9. So it's more like this thing, it ends up being 8 over 9. I'm not sure if you guys got that part, because normally in exam it doesn't get complicated than this. So if you can make sure that you fully understand this one, then you should be ready for any exam type question.
sir, can I ask?
Yebo.
What if the bases on the bottom were not the same as the bases on the top?
Let's say at which stage or at which step, on which step can we use as an example to explain?
On the third step.
Let's say maybe step number 1, 2, 3. On this step.
Yes. Yes, sir.
Okay, so I'm just not sure of how to explain this so that I answer your question directly. But remember, you only work out those that have the same basis. For those that do not have the same basis, you just leave them as they are. For example, after those two cancelled each other out, you only have 3, which is the only one having a base of 3. So that is why throughout my steps, I kept on writing it as it is because it doesn't have another same base. But I only concentrated on those that had the same basis. So that means you only focus on those until you get to something similar to this. So examiner knows that once you get to this, that's when you will start working it out with that one. I'm not sure, honorable member, if I try to answer your question there.
Sir,
Yes,
may I please ask a
sir.
question?
Yes.
Sir, isn't there an easier way to do this?
Hey, it's more like you're saying, isn't there a shortcut? And there's no shortcut, honorable member. There's no shortcut. I'm just trying to think if maybe it can be done differently. Maybe let's try something. Let me remove all of this and let's try something differently just to check if it will make any difference. Let's quickly see. We've done this already, so I'm just going to be quick on this. We know is 2 to the exponent 2. Okay, maybe let me not take shortcuts and do that. And then for that one, we said is 3 to the exponent 2 n minus 1 all over this is where I need you guys. What was that? It
2
was
to
2
the
to the
exponent
exponent
3.
3 times 3 to the exponent 2, nay,
2.
multiplied
Yes.
by 2 to the exponent 1 minus n. Okay, power to power there. So we're having 2 to the exponent 2n plus that being 4 multiplied by 3 to the exponent power to power 2 that power to power that is 2 over power to power 2 to the exponent 2n power to power 3 to the exponent 2n multiplied by 2 to the exponent 1 minus n. Okay. So let's say this Bantu Bakit. Let's say because we are having the same basis, let's just straight away try to write this as just one linear expression, meaning we just don't write it as a fraction. And how do you do that? You are allowed to write it as 2, being a 2 that is going to represent this 2, that 2, and also that 2. So this is that 2. Now let's work out the power. So can you see the powers at the top? You write them as they are, as 2n plus 4. But the powers at the bottom, you then change their signs. Can you see this thing is 2n? That means you write it as minus 2n. Can you see this thing is positive 1? You write it as minus 1. Can you see this one? You write it as an opposite sign. It's going to be that. Then you say multiplied by. Now you are going to move to the basis of 3, which is only those 2. So they are represented by that. So the ones at the top, you write them as they are. But the ones from the bottom, you write them with the opposite sign. It's positive 2n, you write it as minus 2n. So can you guys see? I think this is a shortcut. Also, this shortcut of doing this, you only do it if you don't have a sign of a plus or a minus in between. Let's say you had 2 to the exponent 2n plus 1. If you had maybe minus, then you have 2 to the exponent n over maybe 3 to the exponent 2n. You can't take this to the top and change its sign. This one having a sign of a plus or a minus is worked out differently, and I'm going to show you on the next problem. But just make sure that you fully understand this one. So now, what do you do, honorable member? Can you see? You just work out the like terms, just like I've explained. You have 2n minus 2n. They cancel each other out. I'm not sure if you notice that. Let's see. I'm just checking if I've made a mistake somewhere. Did I not make a mistake somewhere, guys? I just want to be 100% on that one. Guys, are you sure I didn't make a mistake somewhere? Let's see. I don't think I made any mistake, but I'm suspecting, guys. Okay, let me quickly check something. Whoever who's doing this from their side, can you just confirm if whatever that I've done is the same as what you have done? This is 2 squared.
Sorry, sir, you made a mistake there.
I'm not convinced. I'll just have to redo that part.
Then
Okay.
On
Yebo.
the on 2, it's 2 to the power of 3 instead of 2 to the power of 2.
Yes. There. So with you saying I did not make any mistake, guys, it has to serve as a sign that there are too many mistakes associated with this type of problems, which means you need to pay full attention. I did suspect that I made a mistake somewhere. And the reason to that is because I already knew where it was going to get wrong. Okay, so maybe for the last time, we are having 2 being the base for that 2, this 2, and that 2. That one, it doesn't change. It remains 2n plus 4. For this 2, it goes to the top. It changes the sign. It's minus 3n. This one, it changes sign. It's minus 1, and then it's plus n. Times, can you see the bases now are not for this basis of 3, you work them out separately. You are having 2n minus 2 at the top. This one, it is the one that is going to change a sign. So now let's work out those. Can you guys see that it's more like we are having 2n that you can plus with n is 3n. So it's more like you are having 2 to the exponent 3n. You still have that 4 maybe being plus 4. You have minus 3n being that one. You have minus 1. So it seems like 3n can just cancel out with 3n. Then you remain with 4 minus 1. And 4 minus 1, what is that? Is it not 3? I think it is 3 multiplied by. Here, can you see 2n minus 2n? They cancel each other out. You remain with a negative. So it's more like you now have that. So if you remember, instead of you having to just punch this on a calculator, try to work it out and say, what is that? This is 8, obviously. This is 8. So you can therefore say over 3 to the exponent positive power there, which is what? 8 out of 9. Sure, I'm not sure if this was a shortcut or is still the same as that other one. Which one do you guys think is better between this
The
method
first
and
one.
the first one?
The first
Yes.
Yes, I think the first one, because with the first one you avoid making too many mistakes. Okay, so now let's try to move on to the next question and see how far we can go with that. So with this one, we are having 3 to the exponent x plus 2 minus 3 to the exponent x over 3 to the exponent x plus 1 minus 3 to the exponent x minus 2. Let's just quickly make sure that I've copied it correctly. 3 to the exponent x plus 2 minus 3 to the exponent x, 3 to the exponent x plus 1 minus 3 to the exponent. Yes, I've copied it correctly. So now, first step, let's see. Can you see? This one, you have a minus in between. It could be a minus or a plus. With this type of questions, 100% sure you need to expand those, and you will somehow have to take out something as a common factor. How do you know? The moment you say a plus or a minus, whether at, at the top only or at the bottom only, you need to separate the powers. So you are having that times that minus 3 to the exponent x over, you also separate the powers of those. And then here, you also separate the powers of those. This part, does it make sense to everyone?
Yes, sir.
Yes, sir.
Okay, so now let's see. Isn't there something that we can take out as a common factor there? It is there, 3 to the exponent that. So you remain with 3 to the exponent 2 inside. Maybe let's write it minus. Here, you took out that and then you remain with a 1. Remember, this is you factorizing. You take out something as common factor. And then whatever that remains inside, it has to be the same as if when you say that by that, it takes you back to that. So here, do we not have a common factor? We do have, being 3 to the exponent that, which is there, and then you remain with that being just 3. And then here is there, it's taken out, and you remain with a minus 3 to the exponent negative 2 there. Guys, are we still together up to that stage?
Sir,
Yes.
where did we
Please
get
repeat
the
that
one?
step, sir.
Where did we?
Where did we get the one? On
Uh,
the
this one.
yes, yes, sir.
It's that invisible one there. Just like maybe let's say if you have a plus b, no ab, let's say plus a there. So this is actually invisible 1ab plus invisible 1a. So you just take out a, then you take it to the other side, you remain with that invisible 1b plus. So you can't just leave it as it is because it seems as if it's 0. So that is why you write that one, because you took that a to the outside. Does it make sense there, honorable member?
Sir, one
Yes,
question,
sir.
please.
Thank you.
Someone is asking something. What are you saying there?
Okay, you see number 1, stage 2, ne? 1, 2.
Yes, this
Okay.
one.
Okay. You said we need to expand, ne? 3x, the down one, yeah? You open the bracket. Then is it 3 or 1? Because it's supposed to be,
Eh,
I think it's supposed to be, because it's 3 power 1.
yes. So remember, 3 to the power 1 is the same as 3. So if you punch it on a calculator and say 3 to the power of 1 is the same as 3. So we can still write it as 3, or otherwise, if you like, we can still write it as that. Does it make sense now, honorable member?
Yes, sir. Thank you.
Yeah, so remember, guys, the invisible one, you have it in many cases. When you have x, this thing is the same as you have an invisible one there, which is an invisible positive 1, you still have a power there being 1. So this thing is the same as x. Just know there's always invisible 1, there's always invisible 1. That is why on my very first lesson I said in maths we are dealing with 3 things. If you have a letter being x, just know there are invisible things there. In maths we deal with the sign, the number, and the letter. So here, where is the sign? It's an invisible positive. Where is the number? It's an invisible 1. Where is the letter? The letter is x. And obviously, we know every letter, every number has a power. In this case, it's an invisible 1 again. So just be careful of those invisible values there. So now, I'm sure you guys are done cancelling those out, and you remain with what is 3 squared? Is it not 9? I think that is 9. Obviously, 9 minus 1 is what? It's 8, isn't it? That is 8. Okay. So now we are having 3 minusing, what is it? This to the exponent that. So obviously, you can still say 3 and you say minus. If you punch this on your calculator, it is the same as 1 out of 9. I'm not sure if you guys understand what I've done over there. Guys, does it make sense what I've done there?
Yes.
Then
Yes.
you are almost there. What you can do, you can still multiply the whole of that and you get you can punch all of that and you get your final answer. What are you getting when you punch the whole of that? What are you guys getting when you punch the whole of that?
2,716.
Okay. Here we don't give decimal. So where you simplify expressions, you don't give it as a decimal because they said without using a calculator. So one thing for sure, you wouldn't know the decimal for that. So with us using a calculator on this last stage is because we have simplified it and the last mark comes from you just giving the final answer, but as a fraction and not a decimal. So what is it as a fraction?
36 over 13.
Are you guys getting that same answer of 36 over 13?
Yes.
Yes.
Okay, 100%. So do we now move on to the next question? Can we move on to the next question? Anyone who's got a question with that before we continue? Okay, we will just have to move on. But remember, guys, with you not knowing what to ask, it doesn't necessarily mean that you fully understand. I'm well aware that there are situations where you understood, you don't have any questions, but it doesn't mean now that you don't have any question, you know or you understand. It's not our last time doing this. One thing for sure, before you guys write your exams, we'll still be going through this type of questions. But for now, just make sure that when you go back to schools and when they teach this, you ask those many questions so that you fully understand your teacher. So now, let's quickly try to work out this one, which is that. Just make sure that I'm copying it correctly, because if I get it wrong, we might spend 2 years trying to work it out. So let's see. I think I've copied it correctly. Just make sure that it's 3 to the exponent 2x minus 1 that plus 1. Yes, it's copied correctly. Guys, before I even talk much, the moment I see a sign of a plus or a minus in between, I will need to factorize. Very, very much important there, guys. I will need to somehow factorize. And by looking at this, based on my mathematical experience. Some things they really need experience, and by experience I mean you must have done so many examples such that you know when it looks like this is how to work it out. When it looks like this is how to work it out. And this is why I'm giving you guys some tricks that you can apply, that you must always remember, because questions come differently. You will never know in which way it will come. You might think you understand this chapter of simplifying these expressions and whatever, but there's that one question which will come and you won't even know where to work it out. Let me just give you an example of what I'm talking about. Here comes a question. Is there anyone who can give an input or work out that problem? Maybe someone just give it a try. But before you do that, just mention your name if you are 100% sure of how to work it out. Don't straight away answer that, but mention your name. In case if you've got no idea, also say, unmute and say no idea, so that I'm aware you got my question.
No idea, sir.
No idea, sir.
Okay, two of you say no idea, it's enough. Okay, so this is something that you need to be aware of. What I've noticed is that this thing, you cannot do anything to that. You can't further simplify this. Also, one, you can't further simplify this. So I already noticed that somehow at the top, I might need to have something similar to that might need to cancel each other out. And this is where examiner is trying to be tricky. This thing, Bantubakiti, it is actually the same as 3 to the exponent x 2 minus 1 over that whole thing there. Do you guys see what I've done there? And does it make sense what I've done there? Lindiwe, do you see what I've done there? Can you notice the difference?
No, sir.
Okay, the difference is there you have 2x, but here you have x2. That is the only difference. The reason why I did that is because I
Yes,
wanted you
that's
guys
intuitive.
wait. Let me make sure that you guys got what I explained. Nomsa, did you hear me when I said here you have 2x, but there I'm having x2? Did you get that, Hamisa?
Not really.
Yes, I did get that, sir.
Okay, so I just wanted you to notice the difference. Don't worry for now, with you understanding or not. I'm still going to explain why I did that. Nomsa, remember to mute your mic, honorable member. So the reason why I did that, Hamisa, is because I wanted to have a 3 to the exponent x squared minus 1 over this thing. Doesn't matter whether you put it inside the brackets or not. Let me not put it as yet, so that it doesn't confuse you guys and you wonder if we always put the brackets. You can just leave it as it is. So it's more like here I'm having this thing to the power of a 2 minus a 1, of which this thing can be factorized. This thing at the top, it is now almost the same as y squared minus 1. I'm not sure if you guys are able to see that. And this thing, to factorize it, is it not y minus 1, and on this side is y plus 1? Do you guys notice that? Does this thing make sense here?
Yes.
Yes, sir.
Yeah, so that's why I'm saying with this type of questions, you will somehow know how this type of question is done. So let's factorize that. That means we are going to have 3 to the exponent x. You can start with a -1 and you still have 3 to the exponent x, and then on this side you're going to have +1. The whole of that divided by 3 to the exponent x minus 1. This is where that bracket comes in. So can you see this is exactly the same as
Question.
that? Yebo.
How did the sign change from positive to negative? And is that allowed to be done if there are brackets on top? 2 questions actually.
2 brackets on top. This is where you are, Hamisa, isn't it? You're asking there, ne?
If you change the sign to a negative, which was positive, you change it negative.
Mm,
3
no,
to the
then
power
no,
of
then,
x plus 1.
then it's a
3 to the
mistake.
power of x minus 1.
No, then it's a mistake. You're talking about this one, isn't it?
Both, the one
And
being the
also
one on
this one.
top.
Yes. No, it has to be a plus there. You are not lost, Hamisa. You are on the right track. It has to be a plus because of from the original problem it has been a plus. But wait, guys, do you notice what Hamisa is talking about there?
Yes,
Yes,
sir.
sir.
Okay, 100%. Hamisa, just to make sure, this is the first point that you wanted to make. The other one, what did you say there?
Why can you use this formula of like expanding, but there is a bracket there? Because usually, like the way I was taught is that you do not expand unless you remove all the brackets, then you open the brackets. But I'm confused since you're just opening brackets and there's a bracket on top. And why couldn't you do it the first time, just opening the brackets and stuff? And how did the x from 2x become x squared? How?
Okay, I think I will need to re-explain this one, because once you get this one correctly, you will also understand um, uh, as we continue. I'm not sure. Do you guys still remember in some problems where you have to let something to be equals to something? Let's say, for example, they would say let maybe 3 to the exponent x to be equals to k. So can you see, Hamisa, 3 to the exponent x, if we let it to be k, so it's more like you are actually having k squared minus 1 over here also 3 to the exponent x, it's more like this is k plus 1. Then what you do, you factorize that. How do you factorize that? You are obviously going to have k, it's either you have minus on this side, but on this side is going to be a plus. Then you still have k plus 1. So can you see that cancels with that because they are the same? Then you remain with what? K minus 1. Then because you said let k to be that, then we go back to that from the original equation. So it's more like the final answer is 3 to the exponent, what is it, x minus 1. I'm sure, Hamisa, this way it now makes sense in terms of why we were having 3x 2. I will still re-explain it that way, but do you understand where it comes from with this explanation?
Yes, because I was only taught to use the K method to do that, and the way you were explaining it
Oh,
was
yes.
confusing me.
Okay, now
So,
I see. Now I see. But wait, do you guys understand? So it's more like if you were taught to use the K method, it's fine. But what matters the most, Hamisa, is that that's why I first asked if there's anyone who can do it, because that is the most important part. Even if they taught you, for example, the K method, were you able to notice that this is that problem of the K method? So that is the most important part, guys, where I say if you do more and more and more of this type of problems, you end up realizing that this is that type of a problem, this is that type of a problem, maybe this is that one of the K method, this is the one for the type of whatever. But otherwise, someone who doesn't know about the K method at all, Hamisa, this is what they are going to do. They notice this can be written as that, therefore, it's more like this thing is the same as 3 to the exponent x squared. Then this can be factorized. So straight away, they just do that. If it's a -1, this side is going to be a +1 over 3 to the exponent x plus 1. So it's more like they no longer say let k to be whatever. They just straight away work it out as it is. Then this cancels with that, and you remain with 3 to the exponent that minus that. Does it make sense, guys? Especially now that Amisa reminded us of the K method. Does it make sense to everyone?
Yes, sir, it does.
Okay. So quickly, we will need to try and somehow work out this. I'll skip that 1 or 2 questions that I know. They might take a bit longer. Otherwise, I will quickly do them. Let's see. The first one, we are having 2 to the exponent x, which is equals to 1 over 16. Okay, what's happening here? I notice that here I'm having an equation, meaning I have to solve. What am I solving? I'm solving for x. So that means I need to somehow make this one to be a base of 2 to the exponent of something. So that means you're having 2 to the exponent x. Obviously, 1 over 16, this thing, it is the same as that. I'm just not sure if you guys are aware of that. But before I even do that, let me try that method of honorable member and say 1 over 16 it's equals 2 and do that. Okay, it seems like it's an error. That means here you will need to use your mind. 1 over 16 it's equals 2, shift that thing, it gives me its error. Okay, that means you need to use your head in this case. But do you guys understand what I've done there?
Yes, sir.
Okay, then in that case, you will need to remember that 16, it is the same as what? Is it not 2 to the exponent 4? That is 16. So now that means what you are having is power to power, meaning you're having 2 to the exponent -4. So you now have the bases being the same. That means they fall away, and you can now equate the exponents. I'm not sure. Does it make sense, guys, or am I losing you on that one?
It makes sense, sir.
Makes sense.
Okay, 100%. So quickly, let's move on to this one, which says 3 multiplied by 5 to the exponent x is equals to 0, 6. Anyone who would like to give it a try? This one, just mention your name. Remember, no idea in case if you've got no idea.
No idea, sir.
Okay, this is what you can do. Punch this as a decimal on a calculator and check what it gives you. Punch it on a calculator.
3/5.
Yes, it gives you 3/5. So can you see it's now workable? So even if they give you something as a decimal and say 0.6273, examiner is trying to play some tricks here. It's more like they give you this in decimal, knowingly that they taught you how to convert it to a fraction in grade 10. So in case if you say you can't attend grade 10's lessons because you are now in grade 12, I'm telling you that is very, very dangerous, guys. That's why I always say myself, I studied grade 10, 11, and 12, all these three grades in grade 12, and within 3 months, in March, I was done with metric. So that means you need to know everything, so that you are ready for final examination. So now you just learned that if it's given as a decimal, you can rewrite it as a fraction. So can you see now it looks like it's easy to work with. What can we do? Maybe let's remove that 3. Why do we have to remove it? It's so that we can get to that. So that means we remove everything attached to x. Obviously, whatever that you do on the left, you do on the right. Maybe punch all of that. What are you getting when you punch that on your calculator?
Question.
Yebo.
Isn't it 3,5 or is it 3 times 5? Now I'm confused. Because it looks like a 3,5.
Okay. If you remember, Hamisa, we are having 3 types of multiplication. We have the brackets. We also have this multiplication. We also have that. We also have nothing. Let's see. What did I say last time? I said this one, you only use it
You
when you
said
multiply the
you don't
numbers.
use the dot. You said you don't use the dot when you're multiplying numbers because you may confuse it as
A
like
decimal.
the comma. So
Yes.
yes. So you said you use times. So now I'm thinking it's 3,5 instead of 3 times 5.
Okay, no, I see. I see. So, honorable members, what you need to remember is that when something is written, for example, as 2 to the exponent y, this is not 2. This is an invisible 1 times 2 to the exponent y. So notice the difference there, Hamisa. Is different from 3.5. This is different from 3.5 to the exponent x. So this is 3.5. This is where you can confuse it if it was written that way. But the moment one number has a letter, then this is no longer 5. Then you just know that this is 3.5. I mean 3 times 5 to the exponent. I just remembered something there. Very, very much important, guys. If this thing is written as that, this is what I'm trying to say, Hamisa. This is not the, what is it? This can be confused to be 35 to the exponent x. This can be confused as 35 to the exponent x. And of course, it is 35 to the exponent x, but you need something in between to separate it. That is why we are having a dot and not this multiplication. Because otherwise, if you do that, others write x as that. So you're no longer sure if this is 3x 5 to the exponent x. That is why they used a dot instead. But you get my point, most guys. Do you understand what I'm trying to explain there? Does it make sense to everyone?
Yes.
Okay, so now, what did you get when you punched all of that?
1/5.
1/5. So can you see, just like the previous question, this 1/5 is the same as 5 to the exponent -1. So 1 over whatever is the same as whatever to the exponent -1. It doesn't matter whether it's 1 over 2 to the exponent x, for example. This is the same as 2 to the exponent negative power. So just always make sure to remember that. So can you now see you're having the same basis, meaning you can equate the exponents. I'm not sure if that one makes sense to everyone. Are you guys getting that one?
Yes, sir.
I heard honorable member saying it makes sense. Okay, so now quickly, let me write down this one, which is x to the exponent 1 over 2 is equals to 4. This is one of
Yes, sir.
the most complicated question. I'm sure no one will get this one right. Anyone would like to give it a try? Just mention your name.
Hamisa.
That one, she sounds very much confident. Anyone would like to give it a try, just in case if Hamisa is having a powerful connection there and you just got the message now. The Umis, do you not want to give it a try?
Me, sir, I'd like to try.
Oh, there's Larissa. Larissa, I'm suspecting Hamisa is going to give a correct answer. I want a wrong answer. Can you give me a wrong answer, Larissa?
No, sir.
You're going to give me a correct answer.
Yes, sir.
Okay, go for it. How do we work it out?
So I'm going to put x to the power 1 over 2 in brackets.
Mm-hmm.
And then on the outside, I'm going to say to the power 2 over 1.
Mm-hmm.
Then we're going to equate it to 4 in brackets
Mm-hmm.
to the power 2 over 1.
Hey.
Then we're going to get x
Mm-hmm.
is equals to 16.
No, this one, I
Thanks.
don't trust it. Hamisa. No, not Hamisa. Tandi, Tandi Mukwena. This thing, does it look correct? This one. Hi. Amadlozi yami avumi. Hmm?
No, sir. No, sir. I don't think it's correct.
Hi. Mina namfuthi ngicaba. Ayanda Mphahlele. Ucabangani lapho? What are you cabanging there? Sibusiso Mahamu. Ayanda Mkhize. Yes, give it a try. Someone wants to give it a try, but I'm not sure if you are still there. Qinile Ngidi, was it you who wanted to give it a try? Lindiwe. Yes. Go for it. Just mention your name and go for it. I'm not sure who was speaking there. Okay. Guys, this one is correct. It's 100% correct. What honorable member is doing there? I'm sure this is what Hamisa wanted to give as an answer. So the aim is to remove that bracket, that power there of 1 over 2. So to remove it, you just multiply that power by its inverse so that this 2 cancels with that, this cancels with that, and you just remain with x. Then whatever that you do on the left, you also do on the right. So when you say 4 to the exponent 2 over 1, it gives you 16. That's how you know you've done it correctly. Now that it's explained, does it make sense, guys?
Oh, yes, sir. It does.
Yeah, so this is exactly how you work it out. I want to see if you guys can work out this one. Last year, and this question, for example, it's too complicated. Sometimes it's given 5 marks. Again, anyone who would like to give it a try, you just mention your name and I will recognize you. But just make sure that you ate enough pap, because this one, it will drain your energy. I know. Who's the second honorable member? Who mentioned their name? Voice. Okay. Anyone else who would like to give it a try? Okay. Hamisa, unfortunately, I know very well when you're confident. But voice one, go for it.
Okay, so you're gonna say 3x is equal to
This is
3.
3x. It's
No,
equals
3 to the
3.
power of x
Yes, this is now a 3 to the power of x, okay?
is equal to 3 to the power of 0.
This is equals to that, okay?
So then x is equal to 0.
No. Wait. Where is the 3 coming from? You see now, Voiswa is confusing us. Lindiwe, do you understand what honorable member is doing there? It seems like she's creating a very serious bomb there. Where is the 3 coming from now? Nomsa, do you understand where the 3 is coming from?
It's from the rule.
Okay, what does the rule say?
That anything
of
into the
0
power of
is 1.
0 is equal to 1.
Yes. So this 3 comes from that 3. That means if it was 7 there, she was going to make it 7. Why? Just so that the bases can be the same and she equates the exponents. Is this what you wanted to do, voice?
Yes.
Okay, so now we do the last one, and then from there we wrap up our lesson for today. Then we know we have done all that we needed to do under this part of simplifying this type of problems. That last one is this one, and for real, this one is complicated, guys. Just make sure that you think about it before you can try to work it out. This one, maybe let me try to work it out and say, normally, when we have this type of problems, this is what you would try to do. You try to work out that one so that it has the same base as that. So maybe I know that this is 2 to the exponent what? To the exponent 4, that is 16. Then you're having x, then you're having 2, that and that is equals to. This one, can you see? It's more like that decimal. Let's try to punch that and see how it looks like as a fraction. Let's say 5. Where is that button? Shift is that one. Then inside you say 4. As a fraction, no. Can you see? It gives you a decimal. Then you don't want a decimal. You might need to rewrite it somehow. You remember, guys, we said if you have x square root of y, for example, this is the same as this y inside the square root. There's an invisible one there, which is that one there. You say over this thing there, meaning this thing, it is the same as 4. That 4, there's an invisible one there, which is that one there, over that being a 5 there. Guys, do you understand what I've done there, or have I lost you there?
Understand.
Okay. So now let's see, power to power there. So that means you're having 2 to the exponent, what is it? 2 to the exponent that, then we're having 2 to the exponent x, plus 1, which is equals to. This one also, I can still write it as 2 to the exponent 2, which is that 4. And also that. I haven't changed anything. But notice something. You have the same basis there. What do you do when you have the same basis? You add the exponent. So that means you're going to have, what is it, 4x plus x plus 1, which is equals to power to power there. You're having 2 to the exponent 2 over 5. Just know that when you multiply that by a fraction, that multiplies the number at the top. Or otherwise, you can say 2 times 1 over 5. Whatever that you get, you write it there. So now, let's see. It's more like we have a 4x plus x. What is that? This is 5x. So let's just quickly write it as 5x there. So it's 5x plus 1 there. So now can you see the bases are the same? You equate the exponents, meaning you're having 5x plus 1 is equals to 2 over 5. What you can do is to transpose. Then you have 5x, which is equals to, you are having 2 over 5, that you minus it with 1. Then you can punch that on a calculator. What are you getting there when you punch that on a calculator?
Negative 3 over 5.
Negative 3 over 5. So can you see, we want to remove that 5 there. So whatever that you do on the left, you also do on the right. So that removes that. You remain with x, which is equals to what? What is that one? I think it's negative 3, because those cancel each other out. No. Maybe 3 over 25. Because if you say divided by that.
3 over 25.
Yes, negative 3 out of 25. So that means this is your final answer to that question. Did that make sense to everyone, guys? Are you sure you don't have any questions on that one?
Yes, sir.
No question.
No question.
Okay. I think we'll just wrap it up there. But this is a question that I haven't done. So just make sure that you try it from your side, and then tomorrow, I think whatever that we'll be doing, we'll then start with that one. I'm pretty much sure that this coming, what is it? This coming Saturday, I'm going to give you guys a test. But one thing for sure, as soon as we're done with that, we'll be starting with a new chapter, and then from there we'll be moving on. So something that I wanted to remind you guys, in case if you don't know how to like or to mark the on that notification that tells you what time will be the lesson, you press and hold, and then there's going to be options for emojis. Then you can just like. That's how you register. In case if no one fills in the register, it's more like to the tutor, there's no one who's available to attend. So it's either you do that by filling in the register, or you can just send an emoji. But sometimes you're not able to send message. So make sure to press and hold and like, just like you react on WhatsApp texts. So you just do the same. So in that case, guys, I do thank you very much for joining. My name is Desmond. As always, I'm out.